Programming skills using C. Lecture number 13A, arrays searching. Dear friends, in this lecture, we will learn about learning a linear search. How to search a given number in a list of numbers. This list may contain only 10 numbers or 20 or 100 or thousands of numbers. How are we going to do? And this is one of the first methods we are going to learn. It's called the linear search. After that, we are going to find out whether a given number is a perfect number. And then we are going to list all those perfect numbers in a range of numbers starting from 1. So these two, we are going to work these two problems. So I have here a list of numbers. Altogether, as you see, there are 10 numbers are there. And they're just, they are not in any order. And then I can ask, therefore, is 20 present in the list? Immediately, what would you do? I'm very sure you're going to scan this list and you will see that 20 is present. And yes, you are going to say yes. Secondly, if I ask, is 12 present in the list? Yes, yes. Again, you will see it is there at the fourth position and you say it is present and it's also at the fourth position. Or next, if I ask you if 8 is present, then you have to start scanning from the beginning till the end and you find that 8 is there at the end of the list and then you are going to say again it is yes, it is present in the list. But if I ask you, is 25 present in the list? Again you say 10, no, not 25, 5, not 25, 16, it is not 25, 8 is not 25. You have come to the end of the list and you are going to say, no, it is not present in the list. Now this is called linear search. I start from the beginning of the list, I go till the end. Say for example, I have a basket full of numbers here, written on a coin. Suppose I ask you whether 500 is present in this collection of coins. Then what are you going to do? You're going to take the first coin, check whether that number 500 is there. Yes, you say no, it is not there. You will put it aside. Take the next coin, third coin, fourth coin, 100th coin, maybe. You may find before within 100, but you may not also find. If there are 1,000 coins, you have to go through all the 1,000 coins and you may find that 500 there on the 500th coin, and it may not be there also. Then you say, sorry, I have gone through all the coins, 500 coins, it is not there, or 1,000 coins, it is not there. So that is what is called the linear search. So let us look at the algorithm to find out whether a given number is present in the list. For example, I have got 6 numbers here. First I will say, ask whether 30 is present in the list. So I input this number and I say found, that means it is not the -1. Then I will go into this loop, because since there are 6 numbers, I say from I is equal to 1 to 6. Every time I'm going to ask this question, is E of wine equal to 30? No. I skip therefore. Then I becomes 2. Is E of 2 equal to 30? No. I skip. Then I becomes 3. Then I'm going to ask, is E of 3 is equal to 30? Yes. Therefore, I will come out, break the loop. There is a command called break. I break the loop. I don't have to go further. I come out here. Then if found, that is if found is equal to 1, I say the number is present, or if it is not there, then I say that it is not present. Take one more example. I would like to find out whether 15 is present. So I input 15 here and then found is equal to -1. A1 it is not, is 20, it is not equal to 15. A2 is 10, it is not equal to. Every time I skip, I come to 5. Is A5 equal to now 15? No. I come here, I skip, and A6 is equal to number. I come out of the loop, and at the end of the loop, if found is equal to 1, yes, we have assigned 1 there, it is found. But suppose I input 35, number 35. Found is equal to -1. As you see, I will go through the whole list. Every time I'm going to skip. Every time I have come to A of 6 equal to number 35. No. Then I becomes 7. Still I have not found. I come out of that. Found is still equal to -1. Therefore, I say 35 is not found in the list. So this is how we are going to do what is called the linear search. Now I would like you to write the complete flow chart where you will get the value for n, you input n numbers, and then go on searching the number right from the beginning till the end for a given number, a search number, and then execute this program and show whether it is working. So here we have the program. So A20, I input n numbers into this array. Then I print the content of the array. Then I ask for the number to search. Then I go through the list. Every time I ask is A of 1, A of 2 up to n, whether the number is present. If found is equal to 1, then I say number is present or it is not present. Here, for example, I've got some numbers I have inputted and I'm asking is 17 present in the list? Yes, start from the beginning and I found that 17 is present in the list. Or so in this case, I have some numbers are there. Enter the number you are searching for. 30, I've entered 30 and you find out right from the beginning you go through the list and it is not there. Then you say 30 is not present in the list. So this is how we are going to write the program and give the result. With that, we come to the second problem called the perfect number. We have to find out whether a given number is a perfect number, or we will list all those numbers which are perfect numbers in a range of numbers starting from 1 to maybe 500 to 1000 or 2000, etc. The first question therefore is, what is a perfect number? I have 6 here, 28 here and 496 here. So we have to ask this whether these are perfect numbers. So why are they, these are perfect numbers really? Why are they called perfect numbers? Because the sum of divisors including 1 is equal to that number. Let us take in the case of 6. 6 is there. Well, what are the divisors? 1 is a divisor, 2 is a divisor, 3 is a divisor. 4 cannot be a divisor because more than half of the number. Suppose I add these numbers, I get 1 plus 2, 3, 3 plus 3 is equal to 6 and that is equal to 6. Therefore, it is a perfect number. Let us take the second example, 28. As you see, 1 is a divisor, 2 is a divisor, 4 is a divisor, then 7 is a divisor, 14 is a divisor. I've come to the middle of the number. I don't have to check if 15 is a divisor. It's not possible at all. So I add these numbers. As you see, 14, all these numbers, it becomes 28. Therefore, 28 is a perfect number. Similarly, 496. You can go on finding out all the divisors. We cannot do manually. So I have to use computer to find out whether that number is a perfect number. So how shall we proceed? So you input that number and starting from 1 till the middle of the number, you go on finding out the divisors. How do you find the divisors? You have to take the number modulus I. I starts from 1 till the half of the number and that is shown here. I input number. I say sum is equal to 0. For I value 1 to half the number because I don't have to go beyond half the number. Every time I find the remainder. For example, take example 6. So 6 modulus 1, yes, it is equal to 0. I add 1 to 0, it becomes 1. I come to I is equal to 2. Number 6 modulus 2, R is equal to 0. I add 2, it becomes 3. I becomes 3 because numbers 6 by 2 is equal to 3. So again we find that it is 0. Therefore it is added. The 1 plus 2 plus 3 it has become 6. I have come to the end of the loop. I come out. If number equal to sum. So here I have to ask if number equal to sum. In this case, yes, it is a perfect number. Otherwise for any other number 7, 8, 10, etc. it is not going to be a perfect number. So this is, now I would like you to write a complete flow chart to find all those perfect numbers in a range of numbers starting from 1. You will input the final number in the range and then you will list those numbers. That is what you are supposed to do. So pause the video and then do that. I've written here. So as you see here, in this case, I say one more outer loop is for number is equal to 1 to number is equal to n is the end of the range. So I may enter 100 or 1000 or 2000. Then the same algorithm here for I is equal to number by 2. Every time I'm going to check the go up to the half of the number, find the sum, and I'm going to ask if sum is equal to number, sum is equal to number, it will print that, otherwise go to the next number, etc. Here I have the result for this thing. As you see here, program to find all the perfect numbers. So enter the final number in the of the range. I have entered 1000. I find that 6 is a perfect number, 28 is a perfect number, 496 is a perfect number. So this is, I would like you to write a complete flowchart and C program to find out all those uh, perfect numbers within a range starting from 1 to that final number. Thank you.